All right. Hey everybody. I am going to go over the last pre-lab. I'm just going to go over a few parts of it. I'm not going to go over number one. We're going to start with number two. I've just got a couple questions with people being a little bit confused. So the second one, it wants us to show that the position vector r is given by the following expression. So r equals, what is it? R cosine omega t I hat plus r sine omega t j hat. Sorry for the sloppy handwriting. All right. So you just have to know that r equals x plus y. That's all. So this is going to be x and this is going to be y right here. So when you're looking at a circle and you take a slice of it like this and you have this theta, you're just using trigonometry to solve for where x and y are. And so if you have this triangle and this is theta, which our theta is defined by omega t, this is just defined in the reading. And then this is going to be r. This is our hypotenuse. And then this is going to be x and this is going to be y. So pretty simple. So that we have, so if we have the cosine of theta, that's going to be this over that, x over r. And the sine of theta equals y over r. Which means if you solve for x and y, you get x equals r cosine theta, which equals r cosine omega t. And then y equals r sine theta, which is equal to r sine omega t. So that's pretty straightforward. So all you're doing is adding x and y, then you need the vector component. So r cosine omega t plus, or I hat, plus r sine omega t j hat, and this is equal to r. Okay? All right, so then it wants you to do, it wants you to take the first time derivative with respect to our our vector. So all you're doing is d dt of r equals, you're just taking derivative. So just know that there's a chain rule because this omega is some value at some number. So you have to, so this is r omega cosine, or I'm sorry, this is minus r omega sine omega t I hat plus r omega cosine omega t j hat, and then it just says to show that the magnitude is omega r. Because if you take the time derivative of position, that equals velocity, okay? The time derivative of position is equal to velocity. And that equals, or the magnitude of it, right? So the magnitude of r equals the square root of x squared plus y squared. This is the magnitude. And so this is equal to the square root of minus r omega sine omega t quantity squared plus r omega cosine omega t quantity squared. And I think you all see it, but I'll just spell it out anyway. The minus doesn't matter. So we have r omega squared times sine squared plus cosine squared. I'm not going to write omega t. Same thing. Okay, so then this equals 1, right? So then that equals square root of, oh, this is squared, of r squared omega squared equals r omega. So that's our velocity. That's our velocity magnitude. Now it wants us to get the acceleration. So we do the exact same thing. So we're taking d squared over dt squared, and then we're going to look up here, and so that's going to give us a minus r omega squared times cosine omega t I hat, doesn't matter, plus minus r omega squared sine omega t j hat. And then if you take the magnitude, you square them all, and you're going to get r squared omega to the fourth cosine squared omega t plus r squared omega to the fourth sine squared omega t. Again, you can see that this is going to just equal r squared omega to the fourth times 1. Square root of that equals r omega squared. And that is our magnitude of acceleration. Right? So there we go. We're done there. Now, it wants you to sketch everything where velocity, your velocity vector, all that for part D. I'm not going to do that. I think you guys can figure that one out. Now, the graph, I can throw it on the screen in this video. But the graph has the line where you have your m being your slope. It's confusing because m is also mass, so to not get confused, I'm just going to put m slope or ms, and that is 0.00995. Okay, plus or minus 1.6. Okay, so the uncertainty here is plus or minus 1.6 times 10 to the minus 9th. So this is just something to keep in mind. This is our uncertainty based on the data. Our b doesn't really matter. We're just going to ignore that. And so, again, this is an equation of a line. So if you look at the axes, the force is labeled as y. And that is m. Now our x, be careful here. Our x, if you look at it, it's angular velocity squared. So x is omega squared, okay? So in our full linear equation, mr omega squared, this is the full equation where r omega squared equals AC, right? So if this is our x, that means this must be our slope. mr is our slope. So m slope, ms, equals mr. So 0.00995 equals mr. And m is given to us as 76.5 grams. Okay, be careful, that's not kilograms. That is equal to 0.0765 kilograms, okay? Because force is always, you always use kilograms, all right? So it's something you just have to keep in mind. So we're solving for r. So that means r equals 0.00995 divided by 0.0765 kilograms. And that is equal to, I solved it over here. What was that number? It's about 0.13 meters. Okay, so that is the radius. Okay, so it was a little bit tricky doing that, but that's how you do it. You just had to see that our slope also had our mass stuck in there. Now for the next equation, if you didn't use omega squared, instead of getting a linear expression, you would get y equals ax squared plus bx plus c, where x is omega, okay? So I don't know if you've ever done this trick in algebra or calculus or whatever. Probably like calculus 2, you learned where you match the coefficients, right? So if you have omega squared, and what you want is mr omega squared, right? Because this is what you're trying to solve for. You're trying to solve for r. Then a then equals mr, right? Our big A. And then the B is then 0, and then C, and then C is our little b, but we can just kind of get rid of this, okay? This is all we care about because we're trying to solve for R. And this time our A is 0.00983. A is 0.00983. You can see it's pretty close to the little m we had before. The difference is, and this is what I'm trying to highlight, is that our uncertainty this time is 9.4 times 10 to the, what's that number? 9 to the, I can't really see it. Can I zoom in? I don't know. It's to the -9, let's just say, okay? And so it's a bit, the point is it's a bigger number than this one up here, than this other sigma we had. It's a bigger number. So we have more uncertainty using the quadratic formula, but you get about the same thing. When you divide this by 0.0765, like you should, because you're solving for r, so you just divide by the m, right? So a over m equals r. Then you get a radius of 0.128 roughly meters, something like that. And then, so you can see it's pretty much the same. It's a little bit off, but your uncertainty is greater. So it's better to use omega squared and to do the linear relationship. Okay? I hope that cleared things up, and I'll see you all on, well, let's see, is there anything else I need to go into here? Why does the water not spill? I think you guys can get the rest of these pretty easy. Okay, cool. I'll see you guys on Monday. Thanks.